You are working on the wave on a string phet. And I believe that the worksheet itself that steps you through should have pretty good instructions and information and help about how you do that, but I'm also going to walk you through that on this. So this is the worksheet that goes with it, so you'll answer those questions at the beginning. A transverse wave is what I think of as like a regular wave, where the wave motion is perpendicular to the direction that the wave or the energy travels. This is in contrast to a longitudinal or a compressional wave, where, like, if you take a slinky and instead of moving it side to side, you just kind of give it one good shove, that would be like a compressional wave. A transverse wave is if you take your slinky and you've got it spread out and you move the slinky side to side, so you have that kind of snake-like movement. That's a transverse wave. Speed is how much distance is covered in how much time. We calculated this at the beginning of the year. Some of you did some really neat things with this in your green packet too, where you had your mom or dad time how long it took you to run down the block, or you timed how long it took your dog to run 9 meters across the backyard. This is the same thing. We're just using it a slightly different application where we're looking at waves. So how far does a wave travel and how much time? We're using wavelength for the distance, and frequency tells us how many cycles in, again, how much time. So how much distance is traveled in how much time. So for the sim, you're going to go to the phet app, just here. You're going to go all the way to the bottom and find the wave on a string sim. So there it is. You're going to change some settings. One of the things you want to do here, let's first change damping down here all the way down to none. Tension right here, you're going to set to the middle. You want to turn on the ruler because that's how you're going to measure wavelength. Pay attention to the units that the ruler is measuring in. It's measuring in centimeters. When we calculate wave speed, we're calculating wave speed in meters per second. So this is measuring in centimeters. You will be recording your wavelength in you'll be measuring it in centimeters and then recording it in centimeters. But before you do your calculation for wave speed, you'll need to convert it in meters. You can do that. There are 100 centimeters in 1 meter. So that will be a conversion where you move your decimal point 2 to the left because there's 100 centimeters in 1 meter. Okay, other things we need to change. I change it to slow motion because when it's on normal, it goes too fast for me to be able to kind of pause it at spots where I want to pause it. I'm also going to change it up on the upper right here to no end so that that wave doesn't interfere with anything else. And then I'm going to change it to oscillate in this top left. Now the wave is oscillating at a constant rate. You can see that what we're going to call the oscillator on the left there, as it moves the wave up and down, the string of beads up and down, there's a green bead, a green dot on the top of that oscillator, and that's at 0 centimeters. So that is what we are going to use as our starting point when we measure wavelength. So let's take a look again at the sheet. We've changed all those settings. What you're doing first here is you are setting the frequency at a certain frequency, measuring the wavelength, and then using that to calculate the wave speed. So this first one, well, not first one, the middle one is done, and that's the one we're going to look at as an example. So at 1.5 hertz, we want to measure the wavelength in centimeters, convert it to meters, and then calculate the wave speed, multiplying the wavelength and the frequency. So let's take a look at that. Okay, the frequency is down at the bottom here. The frequency is already set at 1.5 hertz. If I want to measure the wavelength, I need to measure between 2 identical points on the wave. The easiest way to do that is measure crest to crest. So I'm going to pause the sim at the point where the oscillator, the green bead on the far left, is at a crest. So let's do that right there. So we've got a crest. The green bead on the far left is at the top of a crest, the top of the oscillator. We want to follow that down and up until we get to the next crest. And that is about 2.5 2.5-ish. So that's your wavelength. So 2.4 is what I'm measuring on here. 2.4 centimeters is the wavelength, so crest to crest. So I'd go back here and enter that. When I made this first example, I measured at 2.5, so that's what I have here, 2.5 centimeters. Convert that to meters, so that's 0.025 meters. Then if I want to figure out the wave speed, I need to multiply the frequency by the wavelength. So frequency is 1.5 hertz times the wavelength in meters is 0.025 meters. Multiply those, do the math, and my wave speed is 0.038 meters per second. Then you are going to go back and you're going to change the frequency to each of these different frequencies. Do the same thing, measure the wavelength. So let's go back and change it to, we can change it to 0.5 hertz. Okay, so 0.5 hertz. I'm going to let that go for a minute. Let it get at this new frequency. And then I'm going to try and pause it again when the oscillator, that green bead on the left, is at the very top of the wave. There we go. Okay, so that is our 0. I want to measure the wavelength. So from that crest to the next crest, which is kind of in the window there, so that's a little bit tricky to measure, and you might need to do some guesstimating. What I actually did is just held up a piece of paper to kind of get a sense of how far 1 centimeter is on this ruler. And then I guesstimated, I don't know, what does that look like? 7.4-ish, something like that. So that would be your wavelength. So let's say 7.4 centimeters or whatever you measure it at. You would enter that into the wavelength in centimeters, convert it to meters, set up your math for frequency times your wavelength, and calculate your wave speed. Then you're going to answer 2 questions here about the relationship between wavelength and frequency. Then the next thing you're going to do is frequency. So frequency, remember that frequency is how many cycles are in 1 second. That's what a hertz is how many cycles per 1 second. The sim actually measures that. Well, that's what you're setting is the frequency. What we're going to do is we're going to try and count how many cycles per second so that we can prove to ourselves that the frequency it matches what the frequency is that we're setting on the sim. Counting how many cycles in 1 second is going to be real tricky because that's too short of a time to be able to count, well, how many cycles, how many waves went through in that time. So what we can do is count how many cycles pass in 10 seconds. So here's how you're going to do that. How many cycles pass in 10 seconds? You are going to go here. Let's let that go. If you toggle on the timer in the lower right there, that timer now is going to time. You could also use a timer on your phone if you wanted to. Just all you need is a timer, but there's one built into this. So when I start that timer, I am going to count how many times the oscillator, the green bead on the left, reaches a crest. That's going to give me 1 cycle. I'm going to count how many times that happens in 10 seconds. So I'm going to start my timer right now. It's 1, 2, 3, 4, 5, and that's 10 seconds. So there were 5 cycles in 10 seconds. So if I have 5 cycles in 10 seconds, and I want to know how many cycles in 1 second, then I would take that 5 and divide it by 10. That means my calculated frequency is 0.5. There's 0.5 or half of a cycle in 1 second. Hertz is how many cycles per 1 second. And that matches the frequency that I had set on the app, on the sim. So the frequency was set at 0.5 hertz, which matches what I counted on that. Again, you're going to have some questions that go with that. Then your last bit here is a question, what's the relationship between frequency and wavelength? This is more or less the same question that you had after your first data table, but this time you're structuring it in the format of a CER. So your claim answers that question. What is the relationship between frequency and wavelength? Remember the terms we use to define relationships, direct or inverse. None would mean that there is no relationship between them, that if one of them changes, it has no effect on the other. So how does the relationship between those two, how do they interact, or how do they influence each other? Does one of them increase when the other decreases? Do they both increase or decrease together? That will be your claim. The relationship between frequency and wavelength is what? Your evidence then will be from your collected data on the sim. So what evidence do you have, what data demonstrates that your relationship is whatever it is that you said it was in the claim? Your reasoning then is a discussion. It connects your evidence to your claim. So in your evidence section, you cited what data you have. Okay, now the reasoning goes, okay, so what? How does that evidence support your claim? Your reasoning is also a chance to demonstrate to me what you understand. So remember that this is your discussion where you are proving to me that you understand how these variables relate to each other, how these variables affect each other. Enjoy.